is the next video. This is, we're on number 8 of the Unit 9 review, starting to go over inverses. So these are actually the notes that we just took on Thursday. So they should be the freshest ones in your mind, but remember to find an inverse. We have to switch x and y. So we're replacing f of x with y and switching x and y. So that becomes x equals negative y plus 2 cubed. To solve for y then, we need to get rid of that negative in front. So we've got negative x equals y plus 2 cubed. Now we've isolated the cubed expression. We're ready to take the cube root. And so we've got the cube root of negative x equal to y plus 2. And so now we just have to move the plus 2 over by subtraction. Now, remember when we were doing these notes, I kept reiterating, when you're adding this last constant or subtracting whatever you're doing to move a constant over at the end, it's not going to go inside, whether it's parentheses or a radical here. So it's going to be outside. So this should come out to be the inverse is the cube root of negative x, and then the minus 2 is outside the radical. So that is the equation. So there's the original function, and there's the inverse. And then we graph those, practice graphing. So the original is the cubic function shifted left 2 and reflected. Okay, so I could graph this by hand, but I am going to encourage y'all to use Desmos for your graphing needs. Let me minimize that, make that a little smaller. Come on. There we go. Okay. So I like to have the line y equals x in there as a dashed line. And then I'm going to put the original in. Make it the green. And then I'm going to put the inverse that I found in. Remember, cube root is down here under functions at the very bottom. You have to put the 3 in to make it a cube root. Negative x, then that is minus 2. Okay, and you can zoom out on this, you can recenter this, but you can see if I were to fold it along this dashed line, all of those would line up. So we can now go and graph this on our graph. You can pick points to plot. You can see your point of inflection for the original is at negative 2, 0. And you've got a point at 3, negative 3, 1. Okay, and you've got a point at negative 1, negative 1. And you've got a point up here at negative 4, 8. Okay, so you can plot some of these points. It's hard for you to see by clicking to get points and you're asked to graph, remember you can always make a table. And get that equation. I'm going to copy it and put it in here. The only thing is it needs to be x1. So after the x, put a 1, and it'll put that as a subscript. So you can make a table for that original equation and points you want to plot. So I want to plot something over negative 4, negative 3, etc. So there's some points you can plot for the original, and then you can do the same thing and make a table for this one. Now this table, you saw that said x2, so we're going to make sure this says x2. Because that was x2, this is x2. And it's 2 instead of 1 because we already have one up here that's x1, so we can't repeat the same value. So for this one, let's see, it looks like there's a point there close to maybe negative 8, so let's try that. Yep, negative 8 and 0. And then You can keep putting in points. Now, some of those are decimals. We're not going to plot those. Wait till look, we got another integer, integer, integer. Okay, some more decimals, and then you get another integer. Okay, so you can always just use Desmos to create the tables for you rather than having to do those by hand. Okay, and you can see as I made the table, it put all those points on there. I didn't realize it did that when you made a table, but there you go. So I am going to just take it for the sake of our notes. Zoom out so we can get that point up there at 8. There we go. I think we see them all there. And I'm going to just grab a screenshot of this. And put it in here. If it will let me. Huh. That's strange. It's not letting me paste the image. Okay, well, let me just go back to it for you to see one more time. You can pause it while you draw yours. Okay. All right. Now let's look at 9. 9 starts with the cube root function. So I'm going to switch the x and y. So it's going to be x equals the cube root of y minus 3 plus 2. So to solve for y, I first need to isolate the cube root. So subtract 2. Now, to get rid of the cube root, the opposite operation is to cube. So we're cubing both sides. Remember the entire side. So the x minus 2 goes in parentheses and is cubed. So we have x minus 2 cubed equals y minus 3. Now I'm ready to move the 3 by addition. And again, that 3 is not inside those parentheses. It's not part of what's being cubed. So make sure it's on the outside. So when you go to write the inverse, you could write that as x minus 2 cubed with the plus 3 out in the back, or you could have written 3 plus in the front. That would have been correct as well. So there's your inverse. And then I would go to my Desmos. My original function is the cube root of x minus 3 plus 2. And the inverse I came up with is x minus 2 squared plus 3. So we can, and I'll switch the colors. This is the original. This is the inverse. Oops. There we go. So you can see those are indeed inverses. So we did the work correctly. And you can go ahead and plot these points. You can see your point of inflection for this one appears to be at 3, 2. And the point of inflection for the inverse, okay, is at 2, 3, which makes sense because 3, 2 switch to 2, 3. Okay, remember your x and y switch for inverses. All right, no more graphing on those. We're just finding the inverse algebraically. And again, if it was a multiple choice question on the test, you can still do it graphically. You can plug this in and then plug in answer choice 1 and see if they're inverses. If they're not, erase answer choice 1 and try answer choice 2. See if those are inverses. Okay, but again, always keep, when you're checking for inverses, I like to keep that line y equals x in there as the dashed line to make sure I can see that it's reflecting across that. All right. So we're going to switch x and y. And now we need to solve by moving the 7 over. X minus 7 Now I need to get rid of the coefficient of -1. Now again, everything gets divided by -1. Now dividing by -1 just means you're changing your signs. That's pretty straightforward. So the x is going to become negative and the 7 will become positive. Now we've isolated the cubed term and we're ready to take the cube root. So we removed the cube from that side of the equation and are left with just y minus 2. And then I'm ready to move the 2 by addition. Now again, this is under a radical. This 2 is not. Do not combine that 7 and 2. Common mistake to make. Don't be the one to make it. So the inverse is the cube root of -x plus 7 and then plus 2 on the outside. And you can check it graphically or you can check it algebraically how I showed you as well. All right, here x is equal to y cubed minus 5. Also remember what I said. If you start with a cube, your inverse should be a cube root. If you start with a cube root, your inverse should be a cube. Okay, so you can sometimes eliminate answer choices that way as well. So I'm going to add the 5 over. Get rid of the 2. Everything over there is divided by 2. Now I'm ready to take the cube root to eliminate the cube. Remember, the entire side we're taking the cube root of. So a couple ways you could write this. You could write it as the cube root of x plus 5 over 2 all together like that, which is probably where I would leave it, because even if I separated and did the cube root of the numerator and denominator separately, 2 is not a perfect cube, so it doesn't simplify. So I don't really see a point in doing that. So I would just leave it like this. The only other way I think you might see an answer choice for one like this is still all under the cube root, but separating the denominator of 2 and making it 1/2 x, because that's an understood 1. So 1/2 x plus, and then the 5/2. So it's possible you might see it written that way instead, but most likely it would stay like that. All right, here, switch x and y. Remember, we're replacing f of x with y. That is our y. Now we're ready to solve for y, and there's nothing outside the function to move. We're ready to cube, to get rid of that cube root. Now we need to move our constant. And now we need to move our coefficient. Everything gets divided. So again, a couple of options on how you would write this. Put it back in function notation as the inverse. You could leave it x cubed minus 2 over 2, or you may see it written where the 2 is split between the 2. It's the denominator of both, so it would be 1/2 x cubed, but then it would be minus 2/2. But 2/2, that reduces. 2 over 2 is simply 1. So in that situation, I do see maybe it being rewritten like this because of that being able to reduce. So both of those are technically correct ways to write it. You need to know if one of those, if you get this, but don't see it as an answer choice, this is there, that means the same thing. And you can always check that they mean the same thing, that they're equivalent by plugging them both in Desmos, and the graphs should be the same. All right, so we're going to stop that video here. If you need to get the rest of this, that'll be in the next video.